We're continuing 9-2 notes. We're on number 18. The instructions still say to evaluate and or simplify. I want to take negative 32 raised to the 4/5 power. In this problem, the negative is not being raised to the power because it's not in parentheses. So what I'm actually doing here is the negative or the opposite of the 5th root of 32 to the 4th power. I'm going to do this as the opposite of the 5th root of 32 to the 4th power because it's easier to take the 5th root of 32 than it is to raise 32 to the 4th power, especially if you're not using your calculator. Okay, the 5th root of 32 is 2, so now I have 2 to the 4th power and still have the opposite of that. Again, that negative is not being raised to the 4th power. It is not inside parentheses. 2 to the 4th power is 16, and that gives me negative 16 as my answer. On number 19, I have negative 32 to the 3/2 power, which means, again, the negative is not in parentheses, so I have the opposite of the square root of 32, and that amount cubed. The negative, again, outside the parentheses because it wasn't inside parentheses being raised to the power. So I want to take the square root of 32. Well, 32 is not a perfect square number, so there is no square root of 32 that's an exact answer. If I take 32 and raise it to the 3rd power, there's still no square root of that number. So the only thing I could do with this one is approximate the answer. That means take the square root in my calculator and then cube that number and approximate the answer, which would give me approximately negative 181.02, and that's the best I can do with that. Okay, on number 20 now, the negative is in the parentheses, so I'm taking the square root of negative 32 raised to the 3rd power. Can I take a square root of a negative number? No, not in the real number system. I can't take a square root of a negative number, so I can't do that problem that way first. So let's think about if I take negative 32 and raise it to the 3rd power first, or cube it, and then take the square root of it in that order. Well, if I take negative 32 and raise it to the 3rd power, the 3rd power is an odd power, which means I would still have a negative number, and therefore I would not be able to take the square root of it because I can't take the square root of a negative number, so that simply has no solution. Number 21, 4c to the 4th power, all raised to the 3/2 power, means I have the square root, that's for the denominator of 2, of 4c to the 4th, all cubed. Because again, it's easier to take the square root of 4c to the 4th than it is to first cube it. I work with smaller numbers. So the square root of 4c to the 4th is 2c squared, and now I'm going to cube that. 2 cubed is 8. C squared cubed is c to the 6th. Again, of course, I do not have to worry about absolute value signs because I had an even index here, I had an even power here, and I had an even power when it came out, so I did not have to worry about absolute value signs. On number 22, I have negative 27 m cubed n cubed to the 2/3 power, which means I'm taking the cubic root of everything in the parentheses, negative 27 m cubed n cubed, and I'm taking that and squaring it. Again, I could have squared first, but since negative 27 is a perfect cube, and obviously m cubed and n cubed are as well, it's easy to do the cubic root first. Cubic root of negative 27 is negative 3. The cubic root of m cubed is m, and the cubic root of n cubed is n. Now I want to take that and square it. When I square negative 3, I get positive 9, and that becomes m squared n squared. Okay, number 23, I have 36 to the negative 3/2 power. I want to leave that negative in the numerator because that's going to be my power, and I can deal with a negative exponent, whereas I can't deal with a negative square root. So I'm going to take the square root of 36 to the negative third power. Well, the square root of 36 is easy. That's 6 to the negative third power. Remember, when we have a negative exponent, I make it positive by moving it to the denominator of a fraction, which makes that 1 over 6 to the positive 3, which gives me 1 over 216. And again, remember, these can be done in your calculator. If I want to raise to a fractional exponent, I put my base 36, then use the up arrow or caret button, and then parentheses negative 3 divided by 2 end parentheses, math enter, and it gives it to you. Again, I was going to try to show you these on the calculator, the 83 calculator on the smartboard screen, but unfortunately this smartboard does not have the calculator on it, so I can't do that. We'll do more of that in class when we're there. Okay, number 24, negative 32 to the negative 3/2 power. I'm taking the square root of negative 32 and raising it to the negative 3 power. Well, that negative 3 power, remember, means that's actually 1 over the square root of negative 32 cubed. I can't take the square root of a negative number in the real number system, and even if I were to cube that negative, I would still have a negative because I would be raising it to an odd power, so therefore there is no solution to that problem. Nothing I can do with that one. For number 25, I have negative 27a cubed to the negative 2/3 power. That's the cubic root of negative 27a cubed, all raised to the negative second power. The cubic root of negative 27 is negative 3. The cubic root of a cubed is a. I'm going to raise that to the negative second power, and still, if you remember from your Math 03, a negative exponent moves it to the opposite side of the fraction bar. We had that in our rules a minute ago. So this becomes 1 over negative 3a to the positive 2, which gives me 1 over 9a squared. Number 26, I have a to the 2 over 7 times a to the 3 over 7. Remember, the rule is when you have like bases, you add their exponents, which gives me a to the 2 over 7 plus 3 over 7, which is a to the 5 over 7, or you could say that's the 7th root of a to the 5th, depending on whether you want it left in rational exponent form or whether you want it left in radical form. Number 27, I have 5 to the 2/3 power to the 3rd power. Remember, when you're taking a power of a power, that means one base raised to 2 powers. The rule is multiply those powers. So that's 5 to the 2 over 3 times 3, which you can write as 3 over 1 if it makes it easier to multiply. 2 over 3 times 3 over 1 is 6 over 3, which is 5 squared, and 5 squared is 25. On number 28, I have a to the 2/3, b to the 1/2, all raised to the 6th power. So again, the rule there is when you're taking a power of a power, multiply your exponents. So that's a to the 2 over 3 times 6, b to the 1 over 2 times 6. 2/3 times 6 is 12/3, which is a to the 4th. b to the half of 6 is 3, or 1/2 times 6 is 6/2, which is b cubed, and that's your final answer, a to the 4th, b cubed.